Today, we're going to talk about the how application of the TP. So let's solve the problem with the concept of the dynamic program. First of all, sorry for the delayed the classroom. All right, so let's solve the LIS, longest increasing subsequent. Okay, so LIS problem is finding the length of the longest subsequence of the given sequence, such that all elements of the subsequence are sorted in increasing order. Okay, this is your input. My job is, among the subsequences, I want to find the longest increasing subsequent. In this case, 10, 22, 33, 50, 60 is my solution. 1, 2, 3, 4, 5. Length of 5 is my solution. When the input is long enough, can I find the LIS fast enough? Do you understand the problem? So problem is find the LIS in a given subsequent, given the sequence. Say, okay, anyway, so problem is, let's say there is the sequences and I want to find LIS of given input. How can you find it? So what's your approach? Let's think about for 2 minutes, then we can discuss together. Then I'm gonna ask the students who has a relatively lower attendance score. So I'm gonna ask you the 신예진, and I'm gonna ask 오하영, then 고서영, maybe 승재 Kang, and PK. Do you understand the problem, right? So your job is finding LIS in a given sequence.
Can I ask one thing?
Yeah.
On the solution, the longest increasing subsequence, why there isn't a 9?
9?
Yeah,
you could...
I don't think I understand the problem.
Okay, let's say you're starting from the input, starting from 9, then 33 or 9, 21, 50, this is 50, 40, 60, and 60. Length of 4. You cannot make a length of 5.
I think I got it. Okay. Thank
Professor?
You. All right.
Professor?
Yep.
So the problem is, are we going to consider the numbers only after the according number? We are not taking the whole sequence?
Okay, so question is, so this input is given, okay? So you cannot sort them from there. The input is given. In a given problem, I want to find the longest increasing order. Understand? So if I pick the 10, the after should be bigger than a 10. Then I can make a 10, 22, but I cannot make a 10 to 9. Then 10, 22, then 33, 33 is possible, and 21 is not possible. 50 is possible. Then 41 is not possible, but I can put it in here, 41, 41, and 60 or 60. So lengths of 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Only 2 cases.
Okay, I got it. Thank you.
Okay. What? Okay, erasing function is not enabled because I don't pay it. Okay, let's think more 2 more minutes, and I'm going to ask you to think about it. Okay. All right. Ready? Okay. 신예진?
Yes.
Yeah, your approach.
So I thought of starting from the first element.
Mm.
We make a empty list, and the first element is a key.
Mm.
And so add to the list, and then looking at the given sequence, if any element is bigger than the first element added, then append to the list, and then the element just added becomes a new key. So
Okay, I got it. What about 99, 1, 2, 3, 4, 10, 22? If you started as a first point, then you cannot add anything.
So if that's the case, then we can build a new list from the second element, which is 1.
Mm.
And then from the 1, we do the same thing. We add 1 to 34.
Mm.
And then that becomes the new LIS.
So what's the complexity for your approach? So you are repeating, pick this guy and repeat everything. Pick this guy, repeat everything. Pick this guy, repeat everything, right? Then also in this one, let's say this one, starting from here, you are keep expanding it, right? It will grow like this. So complexity is we can put time complexity and space complexity.
The time complexity is maybe O(n) squared.
Yeah, and the space. Space we are also using exponentially. Right? So n square. Okay. Thank you.
Can I try, Professor?
Sure. Give me a second. Okay, Jonghoon Park. Okay, let's ask the others who has a lower score. Oh Young, you want to try?
I'm not sure.
Okay, so go ahead, Jonghoon.
So starting from 10, we need to find a subsequence from 10 from the list, and then move on to next element. If the next element is larger than 10, that means it cannot has the longer subsequence than 10, so just prune it. And if next element is smaller than 10,
cut it.
yeah, cut it. So
You want to cut
we
it?
don't consider the, no, I mean, first find the all subsequence from 10.
Find all subsequence from 10.
Yeah, right. And
33,
remember the longest one.
6,
and move to next. So find the we need to find the longest subsequence starting from 22, but since 22 is larger than 10, we can just ignore.
Okay.
And then move to next node and find the subsequences from starting from 9.
9 to 33, 9 to 21.
Yeah, but still starting from 10 has the longest sequence. And next nodes are larger than 10 and 9, so just ignore them.
Okay, so you keep looking for the smaller value than the initial point. Okay, what's your complexity? Time-wise and space-wise. Time-wise, time-wise you can skip something, but still n square. Space-wise, you're building very long, but you may skip it, right? But so there's a c times and n square. All right, good approach. Thank you, Jungwon. Anyone else?
Professor, may I share my approach?
Sure. Give me a second. Where is it, Jungwon? Sure. Go ahead.
So I thought of using tree. So may I draw on your screen?
Yeah, go ahead.
So if I start from 10, then like I have 22, 9, 33, and also on. And from 22, I also have 9, 33, and all of them so on. And since 9 is not part of the longest subsequence from 22, so I can just prune this 9 by not calculating anything here.
So you initially build up every cases, then you start the pruning, right?
Right.
Okay, then initial buildup, what's the complexity of the initial buildup? N by n, or buildup n factorial, isn't it? In terms of the space.
Yeah, space is n factorial.
Yeah, n factorial. Even you prune it, but you have to initially build up, then you start to pruning it. Right?
Oh, right. Yes, right.
Right. Go ahead. Sorry for interrupting me. Go ahead. Yongho.
Then what if I only choose the numbers that are possible from like 10? Like I omit 9 because it is not possible.
Okay, then that case is like 99, then 1, 2, 3, 4, 5, right? Then you're starting from 99, then you are pruning all the cases from here. But actual answer may start at the second point. Do you got it? So if I started your approaches 99, 1, 2, 3, 100, but you will automatically choose this. All this will be ignored. But
Professor?
Yeah.
Can I see the numbers for 1 second, please?
Okay, Yongho, I got it, and good approach. Anyone else? Okay, let's move on. So, optimal solution. Now we see what is optimal solution. Choose one, and from there, finding all subsequence. Choose one, finding all subsequence. But that is too complex. In terms of space, in terms of time, that's too complex. If you understand the skeleton of the optimal solution, which means we can do we can use previous result, that is dynamic programming. Let's talk about this. So if I do it reverse way, I can do this way. LIS3, LIS4. So if you build from here, build from reverse way, then LIS4 comes with that, meaning this part is repeating, and this part will be repeating somewhere around here. This part may be repeating somewhere around. Okay, now we understand what's the optimal solution. So the easiest way to do is maintaining 2 pointer. So initially, LIS from each point is 1. Okay, then J is fixed, then I is movable. From here, I is here. I is here. Meaning I can update it to 2. I is here. I cannot. I is here. I have this guy, this guy, this guy. Among 3, I'm choosing this guy. Therefore, I could update it. Okay. So this one, 21. Smaller than 21, 3. I have candidate 1, 2, 1, 3. Among those, smaller than 21 is 1 and 1. So I can update it to 2. So from this guy, from 50, smaller than 50, 5 of those, then I can choose maximum number. Okay, then 41, smaller than 41, which is candidate 1, 2, 3, 4, 5 of those, then adding on top of the largest. Okay, smaller than 60. And who's the bigger? So it could be updated 5. So result was like this. 80 was just, I'm just added 31, 50, 41, 60, right? 41, 60. If I'm adding, so up to here was our previous input. By adding this one, so 80, among the candidates, who's smaller than me, I can edit, which is, what's the complexity? So I don't then, so J is fixed, I is looped through, then I can move J in here. Then from here, I can repeat it again. From here, I can repeat it again. Then your complexity look like this. Okay, look like the election sort, therefore n square. But in terms of the space, every time I did n time, then you have to repeat through J times. So it is n square. Clear? Do you see how I done? Okay, let me repeat with the, so our input, 10, 22, 9, 33, 21, 50, 41, 60, then I'm adding 8. This is my input. From my input, I have 2 pointers, J and I. Initially, LI has for itself, everybody is 1. Okay, so I is moved to next one. So from this point, among the candidate who is smaller than me. Okay, so this will be updated to this guy. So I is here still. So I is here 33, who's smaller than me. Among those, I'm choosing the longest one. Then adding +1 is 3, 21. So among those who's smaller than me, I'm choosing +1. Among those who's smaller than me, I'm choosing the +1. Okay, 41, smaller than me, and I'm choosing +1. 60, smaller than me, I'm choosing +1. Smaller than me, I'm choosing +1. Okay, then now I have to move J 1 time. Then I is repeating, keep repeating and repeating. Then this is saved as a 6. Now everybody reset to the 1. Then J is here, I is not possible, I is here. Okay, 2, 21. Okay, 2, 50, adding based on this, 3, 41. Okay, I think do this from this guy, that's 3, 60, do this from this guy, 80, I can do this 5. Then remember as 5. Then I can ignore those. Then J is move on to this guy. Then from everybody is saved as 1. Then you are keep repeating. In terms of time complexity, you have to do n square. What is this line? And in terms of space, I have to have n square, size of n, and you're repeating this, right? So if you can ignore those, which is already that you only save the longest one, then 2 times of n. Therefore, we go over. Clear? Question? No. Go back to the point. So LIS, then I can practice on this one. So we just practice this number, how these numbers are coming out. Can you make faster? So this is baseline, but I'm using, so initially we calculate everything and run it using the optimal structure that is n square, n square. Now I move to n square, n, right? Then can I make it faster? So this is what we've done, n square and n. By discarding by only maintaining the longest one, then I can only need to maintain 2n. Then can you make it faster? Any idea? So until this point, you guys understand, right? Do you want me to try it again? No? Nobody?
Can you explain space, auxiliary space?
Okay, auxiliary space. So you have, so let's say you computed once. Okay, computed once, then it will give you something like this value, 3, 4, 5, 6, right? Then you only record this number, 6. Then you are reset everything to 1, then try again. Reset everything 1 to try again. So how many space did I use? Size of input. And this size of input plus 1 is being used as a result, right? If you want to save the sequence also, then you are maintaining the longest sequence and keep having 1 extra, which means 2n times plus 2, which is still function of big of n. The space for the complexity for the space. Got it? I don't need to store every steps, but I only need to store the longest one, only 1 space. Okay, so your active list is the length of n. Your longest result is 1 space. Good. Got it? I can make faster than this. How? Let's think about a little deeper. How can you make faster than this? Now I have n squared and n. I can even make faster. Any idea? So until this point, you understand it, right? Everybody, if you let's vote. Okay. If you clear until this point, please say something on the chat board. If not, I will gonna explain again. Okay, thank you. All right, so majority of you. So I think a little bit, Hassan was about to say something.
Yeah, so I'm not sure it's going to work when the n is large, but if you look at the 10, we had a 6, right? For the 10, starting from the 10, right?
So input is 10, 22, 9, 33, 21, 50, 41, 60, and 80. So you are saying?
So first time we do the increasing subsequence thing, for the first 10, we had a length of 6, right? But if you look at the 33, even all the numbers are increasing orders, the maximum will be 6. So from there, we can just prune them.
So from 33?
Yeah, even all the sequence are 33, 34, even all the possible maximum increasing sequence is just 6, right?
No, it's 4, right? From 32. 33 is a 4.
Yeah, it's 4, but if 21 was something else and 41 was something else, if all the remaining 5 remaining elements were increasing order, the maximum length of the subsequence from the 33 is 6, right? Did you understand?
How could be 33 could be 6? There's only 4.
Yeah, it's 4.
From 33.
Yeah. It's 4, but if there was some other elements, something else, if there was all the numbers were increasing order from the 33, that would be 6, right?
So
I'm just making some assumption.
Yeah, so 99, 100. From this point, it is 1, 2, 3, 4, 5, 6. Yes.
The length of from 1 is 100, right? Yeah, 100. And if you look at the 22, the possible length of increasing subsequences are 99. So we don't have to look at that because we already have the maximum length that is greater than.
Okay.
This I was mentioning about the pruning.
Oh, okay. All right. So the about the pruning approach. So you have to build something, or when you build up something, from here the candidate, right? Then if you're pruning from much earlier, something like this one. So 99 comes here, 1, 2, 3, 4, 100. Then they'll prune everybody, but you're choosing only this one. The result is 2. So my expected.
If I go,
Go ahead.
Yeah, it's 2. Then we look at the different one, right? The 1, next one, 1.
Okay, 1.
And the possible are 100. Length are 100. And we store them as a maximum length. And from 2, the index is 2, 2, and the length is, what is that, 101. And then the possible maximum length of the subsequence are 99. So we don't have to look at that. Because the max,
Okay, good approach. Thank you. So I think the Hasong is trying to say, I'm sorry, it's about here. We can prune something, maybe we can faster. But I think this is much faster than the Hasong's approach, isn't it? I'm maintaining a short list, and I'm not looping through everybody, but I have just this one control number. All right, so thank you, Hasong. So I even make it faster than this. Sure, 1 second, Hasong. Okay, yep, go ahead.
So if we do not reset the control number, and if my control number is larger than previous one, that means even though try that one, that does not guarantee the longer line, isn't it?
So
Can you
let's say
understand what I'm
we
talking?
are in here, meaning let's say it
Yes.
was 1 before, meaning
Yep.
I'm maintaining the largest one. So my candidate is smaller than 60. This guy, this guy, this guy, everybody. Among those,
Yeah, right.
if I have a hip with the max hip, or if I know the largest number, then I can add it from the largest. I don't need to go all the way to here. Is that what you're saying?
No, I mean, if I mean, if I have some smaller control number, that means I am smaller than the previous one. So
you don't need to do? No, that's not true. Why? Because say my control number, so 99, 100, 1, 2, 3, 4, 5, and 101. So this guy is 1, 2, 1, 1, 1, 1, 1, 1 initially, everybody. Then this guy will only update it to 2. Then this guy maybe start it again, or if you ignore this, it will be all ignored. Is that what you're saying? Right?
Oh, I mean, if I am larger than previous one.
If you are larger than previous one, you are maintaining the LIS, right?
Yeah. So in the case, the 100 has 2. So it means even though I started from 100, that does not guarantee the longer line from starting from 99.
Yeah.
So you can ignore the step starting from 100.
Starting from 100, you can ignore it. Can you use the whiteboard? Can you use my board?
How can I use it?
View options, annotate.
Can you see?
Yeah.
So, I mean, we starting from 99, we recorded this as 2, and under the 1 might be 3. And we need to move to J index here and calculate this. But since 100 has larger control number than 99,
So
you can just ignore it.
Skip the J. Is that what you're
Yeah,
saying?
right.
Okay.
Yeah, right.
Yes. You can skip the J. Yes.
I think that would be faster.
Okay. Good part. But while you're skipping it, there's a proportion to C. Your time complexity, your space doesn't change. I can make it faster than that. Much faster. Thank you, Jung-hoon. Okay, go back to the slide. Okay, how can I make it faster? Any idea? Okay, I will open the solution. So, using the dynamic programming, from here is the more practical DP. How? So I'm going to maintain the active list. Active list meaning size of 0. Among the size of 0, I want to find the largest. Size of 2, I want to find the smallest end. Size of 3, I want to find the smallest end. Why does the smallest end matter? Because I can append it at the tail of it. Among the candidate, I can append the smallest one. If the length is 0, 1, 2, or 0, 10, 11, it's a new result. There are many candidates. Which one should I edit? This guy. This is meaningless. Got the point? Say I have the length of 3, then there's whole new set of there. If I keep maintain length of 3, which one should I maintain? This is meaningless, right? Because whoever I can edit it, I can append it, is more advantage on this point. So therefore, I can keep ignore this guy. So I'm care about the last number. Got it. So my main approach is active list. Active list maintain the every length of it. So size of 1, size of 2, size of 3, size of 4, until that point. Okay. Then from there, how can I edit? So if I have a size of 2, then I'm going to choose which one is a smaller number, the last number. Then I can actively maintain this list. In the end, I can choose the longest one. Why do I have to maintain this shorter length of it? Because I don't know. Some cases like this. So if I practice in here 99, then I can do 99 and 100. Then length of 1, right? 1 is coming in, then I can ignore 99 to 1. Then 2, then 1, 2. Then I can ignore and 1, 2. Then 3 is 1, 3. Okay, 1, 3 and 1, 2. I choose 1, 2. 3, it could be 1, 2, 3. 4 is 1, 4 and 4. 4 and 1. Size of this one. One is more advantage. And 1 to 4 or 1 to 3. Oh, okay, 1 to 3 is better than 1, 2, 3, and 4. 5. Compare 5 and 1. 1 is better. 1, 5. 2 is better. 1, 2, 3. 1, 2, 5. 3 is better. 1, 2, 3, 4. 1, 2, 3, 5. 5 is better. 1, 2, 3, 4, 5. 2, 3, 4, 5. Then 100. 1. Then 100. 1. 1 is better. 1 and 101. And 1 and 2. 1, 2 is a better. Then you keep comparing it. So 1, 2, 3, 4, 101. And 1, 2, 3, 4, 5 is better than 1, 2, 3, 4, 5, 100. You can always guarantee the right answer. And it is adaptable to some odd cases. Do you see how I done it? Okay, let me do step by step. So actively maintaining those. So this is example. So case 1, starting at this one, 0. Only one input, I'm maintaining 0. Size of 8, I can compare at 0 and 8. 0 is more advantage. Then 0 and 8, size of 2. Okay, size of 0 and size of 1 and 2. Then by having 4, I can have 0, 4. Size of 4 is 0, 0, 8, 4, and 0.4 is only possible cases. And I have length of 0 and 4. I should choose 0. 0, 8, and 0, 4. I should maintain 0 and 4. Then I can discard 0, 8. Okay. Then 12. 12, 0. Oh, I can choose the 0. 0, 12, and 0 and 4. I can maintain 0, 4. 0, 4, 12. Okay. By actively maintaining the list, in the end, you'll return 0, 2, 6, 9, 11, 15, which is length of 6. Okay, not 0, 1, but 0, 2. What's the complexity? How many times did I run through? So I need to maintain proportion of this one, right? I don't need to compute everything, but I can discard so many things while I'm actively maintaining it. Therefore, the complexity is n log n. Okay. Do you see how I done it? Not complex. You want me to practice on the board? 0, 8, 4, 12, 2, 10, 6, 14, 1, 9, 5, 13, 3, 11, 7, 15. So my cases is 0, 8. Sharper. 4, 12, 2, 10, 6, 14, 1, 9, 5, 13, 3, 11, 7, 15. This is my input. My job is making 0. Okay, so I'm only running through one time. And this point, 0, 8, I can make 8 and 0, comparing it. I can ignore then 0 and 8. Then 4, I can make 0 and 0 and 4. Okay, 12, I can make 0, 0 0.4, 0, 4, and 12. Now 2, 0, 0 0.2, then 0, 4, 12. Okay. Now I'm 10, 0, 0, 2, 0, 2, 0, 2, 10. I can discard this guy. Now I'm 6, 0, 0 0.2, 0 0.2, and 6. 14, 0, 0 0.2, 0 0.2.6, 0 0.2.6 for 12, 6, 10, 14, 14. Do you see how I done it? I actively maintaining the length of active list, right? Then you can keep repeating. You want me to finish it? Finish this. So where am I? I'm at the 14. Now it is 1, 0, 0, 0, 1, 0, 2, 6, 0, 2, 6, 14. Okay. After 1, there is 9. There's 9. 0, 0 0.1, 0 0.2, 0.6, and 6 and 9. Right. Then 0 0.2, 0.6, 0, 1, 2, 3, 4. After 9, there's 5. Then 0, 0, 0 0.1, 0 0.1.5, and I can discard this. 0 0.2, 0.6, 0.9. Now I'm 13. 13 is 0 0.1, 0 0.1, 0.9, 5, 0 0.2, 6.9, 0, 0.2.6.9.13. Okay, now it is after 13, it is 3, 0 0.1, 0 0.1, 0, 0.1, 0 0.1.3. Then I can discard this guy. 0 0.2.6.9, 0 0.2.6.9.13. After 3, there's 11, 0, 0.1, 0 0.1.3, 0 0.2.6.9, 0 2.6.9.11. After 11, there's a 7, 0, 0 0.1, 0 0.1.3, 0 0.1.3.7, 0 2.6.9.11. After 7, there's 15, then 0, 0.1, 0.1.3, 0.1.3.7, 2.6.9.11, 0.2.6.9.11, and 15. Okay, let me see the result. 0.1, 0.27, 269.11, 269. Yes, that's correct. Do you see how I done? So I run it only once from 0 to 15. I didn't go back, but I only actively maintaining those. So in the view of the time complexity, I run it n times. In the n, I check the length of 1, 2, 3, 4, and 5, right? So this is proportion to the n. Okay, then I want to represent as n log n. In time complexity, in the space complexity, I'm maintaining 1, 2, 3, 4, 5, the proportion of the length of n. That's what I maintain. Clear? Any question about the LIS with the active list? So this is the fastest one. If you can find the faster than this, then you can present on the classroom, then we can discuss together. Clear? Any question? Too easy? So then I want to discuss about the LCS, longest common subsequence. And I think we can discuss about this on Wednesday. Any question about today's class?